On the morning of October 29, 2018, a Boeing 737 MAX 8 took off from Jakarta's Soekarno-Hatta International Airport. The aircraft was 2 months old. It had flown roughly 800 hours. Lion Air Flight 610, bound for Pangkal Pinang, a short domestic hop across the Java Sea. Captain Bhavya Suneja was 31 years old. An Indian national, he had been flying with Lion Air for 7 years and logged 6,028 flight hours, more than 5,000 of them on Boeing 737s. His first officer, Harvino, was 41, with 5,174 hours of experience. By any reasonable measure, these were competent, experienced pilots sitting in the cockpit of a brand new airplane. 13 minutes later, all 189 people on board were dead. 181 passengers, including 38 Indonesian civil servants, 20 of them from the Ministry of Finance, and 10 auditors from Indonesia's Supreme Audit Board. 8 crew members. No survivors. The aircraft had plunged into the Java Sea nose first after a system the pilots did not know existed fought them for control of the airplane, pushing the nose down more than 20 times while they struggled to understand what was happening. That system, the Maneuvering Characteristics Augmentation System, had been deliberately left out of the flight manual. The pilots had no idea what it was, what it could do, or how to stop it. They were fighting a ghost in a machine they trusted with their lives. The problem had occurred on the same aircraft during its immediately preceding flight, the evening before. A replacement angle of attack sensor, supplied by a US-based company called Extra Aerospace, had been miscalibrated. The sensor fed bad data to MCAS. Those pilots recovered using a standard runaway stabilizer checklist. They landed safely. They reported the problem. Lion Air Maintenance did not test the replacement sensor before returning the aircraft to service. No one at Boeing issued an alert. No one grounded the aircraft. No one told the next crew what had happened or what they might face. 4 months and 10 days later, Ethiopian Airlines Flight 302 took off from Addis Ababa, bound for Nairobi. Another brand new 737 MAX 8. Another experienced crew. 6 minutes into the flight, a faulty angle of attack sensor triggered MCAS again. The system began driving the nose down. The first officer, recognizing something was desperately wrong, called out the words that should have saved everyone on board. Stab, trim, cutout. The pilots toggled the cutout switches to disable the electric trim system, which also disabled MCAS. But unlike on previous 737 models, those switches killed all electrical control of the horizontal stabilizer. The only remaining option was to manually crank the trim wheel by hand. At the aircraft's speed, the aerodynamic forces pressing against the stabilizer were enormous. The pilots could not physically move it. They tried. For the remaining minutes of their lives, they tried to move a wheel that the laws of physics would not let them turn. 157 people from 35 countries died. 346 people killed by 2 crashes of the same airplane, caused by the same system, triggered by the same single point of failure. A system concealed from the people who needed to know about it most. This is not a story about a software glitch, or a maintenance error, or bad luck. This is the story of how the greatest engineering culture in American aviation was systematically dismantled over 2 decades, replaced by a culture that measured everything in stock price and quarterly earnings, and how that transformation killed people. It begins in Seattle, in 1916. William Edward Boeing was a lumber industrialist with money, ambition, and a fascination with flight. On July 15, 1916, he founded Pacific Aero Products Company on the shore of Lake Union. The following year, he renamed it Boeing Airplane Company. From its earliest days, Boeing was built by engineers for engineers. The people who designed the machines had authority over the people who counted the money. Cost mattered, but it did not override quality. Safety was not a talking point in annual reports. It was the reason the company existed. Over the next 8 decades, Boeing produced some of the most consequential aircraft in history. The Model 247, introduced in the 1930s, is considered the first modern airliner. The B-17 Flying Fortress became a symbol of Allied air power in the Second World War. The 707, launched in 1958, started the commercial jet age and transformed how human beings move around the planet. The 737, first flown in 1967, would become the best-selling commercial aircraft ever built, with more than 11,000 eventually delivered. Each of these programs carried significant technical and financial risk, and Boeing pursued them because the company's leadership believed the airplane mattered more than the quarterly earnings report. Nothing captured that philosophy like the 747. In the late 1960s, Boeing's president, Bill Allen, made what the aerospace industry still considers the defining act of engineering conviction. He bet the entire company on a wide-body jet so massive and so ambitious that it was internally called the company airplane. Boeing had to construct the world's largest building in Everett, Washington, just to assemble it. The financial risk was existential. If the 747 failed, Boeing would cease to exist. It did not fail. The 747 became the queen of the skies and defined long-haul air travel for 50 years. More than 1,500 were eventually built. Bill Allen, the man who approved the program, watched the first 747 take flight and reportedly wept. That was Boeing before 1997. A company where engineers ran the show and leaders were willing to risk everything on building something great. A company whose internal culture could be distilled to 4 words that every employee understood. We build great planes. Not, we maximize shareholder value. Not, we optimize quarterly earnings per share. We build great planes. The chief financial officer's relationship with Wall Street was not the driving force behind design decisions. The people closest to the product had authority, and when the numbers did not support building the right airplane, the leadership overruled the numbers. To understand what destroyed that culture, you need to understand what Boeing merged with, and what that company's leaders believed in. McDonnell Douglas was formed in 1967 from the combination of 2 legendary American aerospace firms. Douglas Aircraft Company, founded in 1921 by Donald Wills Douglas, had produced the DC-3 in 1935, arguably the most important aircraft in civil aviation history, the airplane that made large-scale commercial air travel possible. McDonnell Aircraft Corporation, founded in 1939 by James Smith McDonnell, became a military aviation powerhouse, producing the F-H-1 Phantom, the Navy's first carrier-based jet fighter, and the F-4 Phantom II, one of the most widely produced and successful combat aircraft in history. Rising development costs forced the 2 companies together. The combined entity manufactured some of the most capable military platforms of the 20th century: the F-15 Eagle, the F-A-18 Hornet, the C-17 Globemaster III, the AH-64 Apache helicopter. But by the early 1990s, McDonnell Douglas's commercial aviation business was dying. Airbus was steadily capturing market share in Europe and beyond. The MD-11 and MD-90 had failed to compete effectively. A proposed double-decker aircraft, the MD-12, never advanced beyond the drawing board. In 1996, McDonnell Douglas shipped just 12 large commercial jets. That same year, Boeing shipped 271 and Airbus shipped 126. McDonnell Douglas had no new commercial aircraft program in funded development, no clean sheet design, no path forward. Its commercial aviation division was functionally dead. What the company still possessed was an extensive defense portfolio, stable Pentagon contracts, and a corporate culture shaped decisively by its chief executive, Harry Stonecipher. Stonecipher was a former General Electric executive who had absorbed the Jack Welch management philosophy in its purest form, financial discipline above all else, aggressive cost reduction as a permanent operating principle, shareholder returns as the ultimate measure of corporate performance, stock price as the scorecard. Engineering excellence was admirable in the abstract, but what the market rewarded was earnings per share. On December 15, 1996, Boeing announced its intention to acquire McDonnell Douglas in a $14 billion all-stock transaction. The exchange ratio was 0.65 Boeing shares for each McDonnell Douglas share, implying roughly $72 per share, a 20% premium to the trading price. CS First Boston advised Boeing. J.P. Morgan advised McDonnell Douglas. 74% of Boeing shareholders and 69% of McDonnell Douglas shareholders approved. The European Commission granted clearance with conditions. Boeing had to terminate exclusivity agreements with 3 American airlines, maintain separate accounting for McDonnell Douglas civil operations, and license certain defense patents to competitors. The deal closed on August 1, 1997. The new entity kept the Boeing name. That was expected. Boeing had written the check. What was not expected was who would actually control the combined company. Harry Stonecipher, McDonnell Douglas's CEO, became Boeing's president and chief operating officer. Senior McDonnell Douglas executives filled key leadership roles throughout the organization. The financial mindset, the GE-style management discipline, the institutional conviction that the stock price mattered more than the product, all of it came through the door with them. An industry saying emerged that captured what had happened with precision that bordered on prophecy. McDonnell Douglas bought Boeing with Boeing's money. The cultural transformation was swift and deliberate. In 2001, Boeing's leadership made a decision that symbolized the change more powerfully than any financial restructuring. They moved corporate headquarters from Seattle to Chicago. After 85 years in the city where Boeing was born, where the factory stood, where the engineering teams worked, where institutional knowledge built over generations resided in the minds of thousands of employees, the executives left. Chicago was 1,700 miles from the production lines. The message was not subtle. Boeing was no longer an engineering company with a business side. It was a financial enterprise that happened to build airplanes. In 2022, Boeing moved headquarters yet again, this time to Arlington, Virginia, in the Crystal City neighborhood just outside Washington, D.C., closer to the Pentagon, closer to defense lobbyists and government procurement officials, closer to the corridors of political power where contracts worth billions of dollars are negotiated, further still from the engineers and factory workers in Renton and Everett who actually built the products that generated the revenue. After the cascading crises of 2024, a Boeing shareholder formally proposed relocating back to Seattle to reconnect decision-makers with the manufacturing and engineering workforce. Boeing's board dismissed the proposal. The leadership that followed the merger reflected the new order. Phil Condit, who had overseen the merger as CEO, resigned in 2003 amid a defense procurement scandal. Stone Cipher replaced him, then was forced out himself in 2005 over an extramarital affair with a subordinate executive. Jim McNerney, yet another GE alumnus, ran Boeing from 2005 to 2015. His previous role was chief executive of 3M. He had no background in aviation engineering. Dennis Muhlenberg followed and oversaw the 737 MAX development program. He was fired in December 2019 after the two crashes. Dave Calhoun succeeded him, another product of the GE executive pipeline. He left the company in 2024 amid the door plug crisis, the DOJ guilty plea, and the machinist strike. Not one of these leaders came from the engineering tradition that had built Boeing. Not one had spent years on a factory floor understanding how aluminum skin is riveted to a fuselage frame, or how a flight control system must account for every conceivable failure mode, or why redundancy in safety-critical systems is not a luxury but an obligation. They understood spreadsheets and shareholder presentations and quarterly guidance. They did not understand airplanes, and they did not believe they needed to. Under their collective stewardship, Boeing's financial priorities became explicit. Between 2013 and 2019, the company spent approximately $43 billion on stock buybacks. $43 billion returned to shareholders through share repurchases over 6 years. For perspective, designing and certifying a clean sheet replacement for the 737, a modern narrow-body aircraft built from scratch with current technology, would have cost approximately $20 billion. Boeing could have funded an entirely new airplane twice over with the money it used to inflate its own stock price. From 2010 to 2014, Boeing's CEO did not mention the word safety a single time in the company's annual reports. 4 consecutive years. The world's largest aircraft manufacturer, in its flagship communication to shareholders, did not reference the concept of building safe airplanes. The outsourcing accelerated in parallel. In 2005, Boeing sold its Wichita, Kansas, manufacturing division to Onex Corporation, a private equity firm. The new company was named Spirit Aerosystems. Spirit took over production of the 737 fuselage, the structural skeleton of Boeing's most commercially important product. The company that had built its own airplanes for almost 90 years had outsourced the construction of the most critical structural component to a firm owned by financial investors. The consequences of outsourcing appeared first in the 787 Dreamliner program. The 787 was supposed to demonstrate that Boeing could still build revolutionary aircraft. It was designed with a composite fuselage, an innovation that promised lighter weight and better fuel efficiency. But Boeing outsourced the design and manufacture of major sections to suppliers scattered across the globe. Components arrived from Japan, Italy, and South Carolina that did not fit together properly. Sections had to be shimmed, reworked, or rebuilt at the Everett factory at enormous expense. The program fell 3 years behind schedule and ran billions of dollars over budget. When the 787 finally entered service in 2011, lithium-ion batteries caught fire on 2 separate aircraft in January 2013, grounding the entire global fleet for 3 months. Investigators found that Boeing had inadequately tested the battery system and relied on supplier assurances rather than independent verification. The 787 eventually became commercially successful, but the program exposed every structural flaw in Boeing's new operating philosophy. The company had learned to count beans. It was forgetting how to build airplanes. The Dreamliner debacle should have been a warning. It demonstrated, in painful and expensive detail, what happens when a company that once controlled every aspect of aircraft manufacturing hands critical work to outside firms whose incentives are different from its own. Private equity owners optimize for cash extraction. Engineers optimize for fit and finish. Those objectives are not compatible when the product is an aircraft that carries hundreds of people at 35,000 feet. Boeing did not learn the lesson. It doubled down. Meanwhile, across the Atlantic, Airbus was taking a fundamentally different approach to the same competitive challenge. Rather than modifying 40-year-old airframes on minimal budgets, Airbus invested in the A320neo program, a comprehensive re-engineering of its best-selling narrow body that delivered meaningful fuel efficiency improvements while maintaining the aircraft's modern design foundation. The A320 had first flown in 1987, 2 decades after the 737. Its design was newer, its systems were more contemporary, and it had the structural margin to accept larger engines without the compromises Boeing would be forced into. The program succeeded commercially and technically. Airlines noticed, and when American Airlines, one of Boeing's most important customers, signaled it was prepared to place a large order for A320neos, the alarm sounded at Boeing headquarters in Chicago. In the old Boeing, the one that existed before Harry Stonecipher walked through the door, the response would have been straightforward: build a better airplane. That is what Boeing did when Douglas threatened with the DC-8. That is what Boeing did when Airbus entered the market with fly-by-wire technology on the A320. When confronted with a competitive threat, Boeing's instinct for 80 years had been to engineer its way out, to build something so good that customers had no choice but to buy it. The 747 was born from exactly that instinct. It was expensive, it was risky, and it was right. By 2011, that instinct was dead. The leadership team in Chicago ran the numbers. And the numbers said that the quickest, cheapest path to keeping the American Airlines order and matching Airbus was not to build a better airplane, but to modify the existing one. Boeing faced the most consequential product decision in its recent history. Option 1. Spend roughly $20 billion and 7 to 10 years designing a clean-sheet, narrow-body replacement for the 737. A modern aircraft with contemporary aerodynamics, modern flight control architecture, and safety systems designed for the current era. Option 2, spend approximately $2.5 billion and 3 to 4 years modifying the existing 737 yet again. Install larger, more fuel-efficient engines. Retain the same type rating so airlines could put existing 737 pilots in the new cockpit without expensive simulator retraining. Deliver sooner, spend less. The culture that Harry Stonecipher had imported chose option 2. The 737 MAX was born. It was the McDonnell Douglas strategy applied to Boeing's most important product, incremental modification of an aging platform instead of clean-sheet innovation. The exact approach that had produced the MD-80, the MD-90, and the MD-11, aircraft that fell behind the competition and eventually vanished from the market. The problem was physics. The new CFM International LEAP engines were larger in diameter than the previous generation. The 737's landing gear was relatively short, designed in the 1960s, and there was not enough ground clearance to hang the bigger engines in the same position. Engineers mounted them further forward on the wing and higher up. This shifted the aircraft's center of thrust and changed its aerodynamic characteristics. In specific flight conditions, flaps retracted, high angle of attack, manual flight. The MAX had a tendency to pitch the nose upward in a way the older 737 next generation did not. Boeing designed MCAS to compensate. The system would monitor angle of attack data and, if it detected a dangerously high pitch, automatically trim the horizontal stabilizer to push the nose down. The intent was to make the MAX handle identically to the previous generation, 737. This was commercially critical because if the handling characteristics diverged significantly, the FAA would require pilots to complete additional simulator training, airlines would incur substantial retraining costs, and the MAX would lose its primary competitive advantage over the Airbus A320neo. The shared type rating was the business case. Billions of dollars in orders depended on it. MCAS relied on input from a single angle of attack sensor. One sensor. No cross-check against the second AOA sensor mounted on the other side of the aircraft. No redundancy. If that single sensor failed or provided false data, MCAS would activate on bad information and repeatedly drive the nose of the aircraft toward the ground, while the pilots who had never been told the system existed tried to understand why their airplane was trying to kill them. There is a term in aviation safety engineering, single point of failure. It means a component or system whose failure alone will cause the entire system to fail. Decades of aviation safety practice have been built around eliminating single points of failure from critical systems. Redundancy is not optional. It is the foundational principle. 2 engines, 2 hydraulic systems, 2 electrical buses, 2 pilots, 2 of everything that matters. MCAS relied on one angle of attack sensor. 1. Boeing made a deliberate decision to exclude MCAS from the flight manual and from pilot training materials. The system was omitted under the principle of maintaining operational commonality with the 737 next generation. The fewer documented differences between the two aircraft, the stronger the argument for a shared type rating. The type rating preserved the economics. The economics drove the decision. Consider what Boeing had built: an airplane whose core structure was designed in the 1960s. Engines that were too large for the airframe and had to be repositioned in a way that altered the aircraft's fundamental aerodynamics. Software designed to mask those altered aerodynamics from pilots so that the airplane could pretend to be something it was not. Software that relied on a single sensor with no backup. Software deliberately hidden from the flight manual so that pilots would not know it existed. All of this to avoid spending the money required to design a proper replacement. All of this to preserve a type rating that saved airlines the cost of simulator training. All of this because the financial culture that had consumed Boeing after 1997 could not stomach the investment required to do the job correctly. After both crashes killed 346 people, the FAA and the European Aviation Safety Agency conducted flight tests of the 737 MAX with MCAS completely disabled. Their evaluation concluded that the aircraft might not have needed MCAS at all to meet certification standards. The system may have been entirely unnecessary from a safety perspective. It existed to protect a commercial calculation. 346 people may have died for a feature the airplane did not require. The FAA's role in the disaster cannot be understood separately from Boeing's influence over it. Through the Organization Designation Authorization Program, the FAA had delegated substantial portions of the 737 MAX certification to Boeing employees. These designees were supposed to function as independent safety reviewers. In reality, they reported to Boeing management and operated under the same production pressures as every other Boeing employee. The Joint Authority's technical review later concluded that if FAA technical staff had been fully informed about how MCAS functioned, the agency would likely have required an issue paper and deeper analysis. The regulator had effectively allowed the company to certify its own product, and the company had certified a system that relied on a single sensor and was hidden from pilots. Boeing's own people knew. Internal messages surfaced during the September 2020 congressional investigation revealed engineers who understood exactly what was happening. One wrote, in words that became the epitaph for Boeing's engineering culture: "This airplane is designed by clowns, who in turn are supervised by monkeys." Others raised specific concerns about MCAS years before the Lion Air crash. The congressional report documented a pattern. Boeing systematically dismissed internal safety warnings, subordinated engineering judgment to schedule and budget pressures, and withheld critical technical information from the FAA China, grounded the 737 MAX first on March 11, 2019, one day after the Ethiopian Airlines crash. Within hours, Indonesia and Singapore followed, then Australia, the European Union, and Canada. Country after country pulled the MAX from its skies based on the same calculation. 2 fatal crashes of the same new aircraft in 5 months could not be coincidental. The United States was conspicuously absent from this list for 2 days, while almost every other major aviation authority in the world had grounded the 737 MAX. The FAA maintained that the aircraft was safe to fly. American passengers boarded MAX flights, while passengers in China, Europe, and dozens of other nations were not permitted to do so. The optics were devastating. On March 13th, under mounting political pressure and after satellite tracking data confirmed the Ethiopian crash trajectory matched the Lion Air disaster almost exactly, the FAA finally issued an emergency order. 387 aircraft were grounded worldwide. Boeing stock had already begun its plunge. The grounding lasted 20 months. It cost Boeing an estimated $20 billion in direct costs. Airlines that had purchased the MAX demanded compensation. Production lines went idle. Thousands of completed aircraft sat parked on runways and in storage lots across the country, deteriorating under sun and weather while engineers redesigned the system that should have been designed correctly the first time. The human cost was incalculable. Families of the 346 victims described a grief compounded by the knowledge that the second crash was preventable. The FAA and Boeing had known about the MCAS flaw after Lion Air. They had issued a bulletin reminding pilots of an existing checklist. They had not grounded the fleet. They had not told pilots that a system they did not know about could seize control of their aircraft. 157 people died in Ethiopia because of that choice. In January 2021, Boeing entered a $2.5 billion deferred prosecution agreement with the Department of Justice on charges of fraud conspiracy related to deceiving the FAA about MCAS. The settlement included a $243 million criminal penalty, $1.77 billion in airline compensation, and $500 million for a crash victims fund. Boeing promised reforms. The DOJ agreed to defer prosecution on the condition that Boeing met its commitments over 3 years. Then a door fell off a brand new airplane. Alaska Airlines Flight 1282 departed Portland, Oregon on January 5, 2024, bound for Ontario, California. The aircraft was a Boeing 737 MAX 9, registration N704AL. It was 2 months old. It had completed 154 flights totaling 510 hours. 6 minutes after takeoff, climbing through 16,000 feet, a door plug on the left side of the fuselage separated from the aircraft. Explosive decompression at altitude. Cabin pressure vanishing in an instant. Oxygen masks deploying. A teenage boy in row 25 had his shirt torn from his body by the blast of escaping air. His mother grabbed him and held on to prevent him from being pulled toward the opening. Seat 26A, immediately adjacent to the hole, was empty. If a passenger had been sitting there, they would almost certainly have been killed or ejected from the aircraft. All 177 people survived. 3 had minor injuries. The pilots executed an emergency return to Portland. The NTSB determined the cause. Spirit Aerosystems workers had removed the door plug at Boeing's Renton factory to repair 5 damaged rivets on the fuselage. The plug was reinstalled, but 4 bolts. The bolts that physically held the plug in place were never put back. Nobody reinstalled them. Nobody inspected the work. Nobody at any stage of the quality control process caught the omission. A 2-month-old airplane flew 154 times, with nothing but friction and cabin pressure, holding a section of its fuselage in place. The NTSB called it a systemic failure of Boeing's manufacturing process and ineffective oversight by the FAA. In March 2024, the New York Times reported that Boeing had failed nearly 3 dozen audits during a subsequent FAA examination. The DOJ determined that Boeing had breached its deferred prosecution agreement. Boeing agreed to plead guilty to conspiracy to defraud the United States, a federal felony. The company accepted an additional $243 million fine and an independent compliance monitor. 2 people who had tried to warn the company about exactly these kinds of quality failures were dead. John Barnett spent 32 years at Boeing, most recently as a quality manager at the Charleston, South Carolina plant that assembled 787 Dreamliners. He filed a formal whistleblower complaint alleging that Boeing had retaliated against him for reporting safety and quality defects on the production line. He described a manufacturing culture where speed was valued over precision, where defective parts were installed because replacements would slow production, where workers who raised concerns were marginalized. On March 9, 2024, John Barnett was found dead from an apparent self-inflicted gunshot wound in his truck in a hotel parking lot. He was in the middle of giving a multi-day deposition in his whistleblower lawsuit against Boeing. He had told friends and family explicitly and repeatedly that he would never take his own life. Joshua Dean was a quality auditor at Spirit Aerosystems who had flagged manufacturing defects in 737 fuselages. On May 20, 2024, Joshua Dean died suddenly at the age of 45 from a rapidly spreading MRSA infection. Both deaths occurred during the period of most intense public and legal scrutiny Boeing had ever faced. In September 2024, Boeing's machinists walked off the job for the first time since 2008. The vote was overwhelming. 94.6% rejected the company's contract offer. 96% voted to strike. The workers wanted better compensation after years of wage stagnation, years during which the company had returned $43 billion to shareholders through buybacks while their real wages declined. In October, Boeing announced 17,000 job cuts, roughly 10% of its global workforce. It delayed first deliveries of the 777X by another year. It reported $5 billion in losses for the 3rd quarter alone. It launched a $19 billion emergency share sale to prevent its credit rating from falling to junk status. The workers settled in November. 38% pay raise over 4 years. A $12,000 ratification bonus. Reinstatement of the annual bonus that had been taken away. The strike cost Boeing approximately $10 billion in delayed deliveries and lost production. It also revealed something that the executives in Arlington might have understood if they had spent more time in the factories. The people who actually build the airplanes knew exactly what had gone wrong with the company, and they were no longer willing to absorb the consequences of decisions made by people who had never touched a rivet gun. By late 2024, Boeing was a company in crisis on every front simultaneously. Criminal charges, a guilty plea to federal fraud, a machinist strike, billions in quarterly losses, an emergency share sale to stave off a junk credit rating, 2 dead whistleblowers, a manufacturing process so degraded that bolts were not being installed, an FAA examination that found failure after failure, and a legacy of 346 lives lost that no amount of corporate restructuring could undo. In August 2024, Boeing appointed Kelly Ortberg as CEO. Ortberg came from Rockwell Collins and Collins Aerospace. He is an aerospace engineer by training and by career. He is the first chief executive with a technical background to lead Boeing in decades. Whether one person, however qualified, can reverse the consequences of a cultural transformation that took 27 years to complete is a question no one can answer yet. In 2005, Boeing sold the factory division that built its fuselages to a private equity firm for a fraction of what it would cost to recover the capability. In 2024, Boeing paid $4.7 billion to buy Spirit AeroSystems back. 19 years of outsourced quality control, reversed at enormous expense, after the damage was already done. Boeing spent $43 billion on share buybacks in 6 years. A clean sheet 737 replacement would have cost less than half that amount. 346 people died because a 50-year-old airframe was modified on a fraction of the budget required, fitted with a flight control system that relied on one sensor and was hidden from the pilots who needed to understand it. A door separated from a 2-month-old airplane because 4 bolts were never installed and no one in the quality chain noticed. 2 people who tried to warn the company about exactly these failures did not survive to see the consequences. The company that Bill Allen once bet everything on. The company that built the 747 because it believed building the best airplane in the world was worth risking its entire existence, became a company that would not risk a single quarter's earnings on engineering. It moved its leaders to Chicago, then to Virginia. Each relocation put more miles between the people making decisions and the people making airplanes. It replaced engineers with finance executives in every corner office. It stopped mentioning safety in its annual reports. It spent the money that could have built the future buying back shares of the present. The question is not whether Boeing will survive as a business. Airlines need airplanes. There are only 2 companies on Earth that build large commercial jets. The order books will recover. The revenue will return. Boeing reported $89.5 billion in revenue in 2025. The question is whether what made Boeing extraordinary, the engineering conviction that produced the 707 and the 747, the willingness to risk the entire company on building something great, still exists anywhere inside the organization. Whether a culture dismantled methodically over 27 years by a succession of leaders who believed the stock price was more important than the product can be rebuilt by the people who remain. 346 people are not here to answer that question. They are the price of discovering what happens when the greatest engineering company in American aviation decides that engineering is no longer the point.